In this lesson, we're going to review some properties already introduced and introduce a few new properties. To start with, let's look at the property of opposites. For any real number n, n plus the opposite of n is equal to 0, and another name is additive inverse property. Here's the additive identity property. For any real number n, n plus 0 is n, also known as the property of 0 for addition, and sometimes called the addition property of 0. The commutative property of addition. For any real numbers a and b, a plus b is equal to b plus a. It's another way of saying that when you're adding up a bunch of numbers, you can add them in any order that you want. The commutative property also works for multiplication. So when you're multiplying a bunch of numbers, you can multiply them in any order you want. The multiplication property of 0 states that any number times 0 is 0. Property of reciprocals. For any non-zero real number n, n times 1 over n is equal to 1. And this is also known as the multiplicative inverse property. The multiplicative identity property states that a number times 1 is equal to itself, and this is also known as the multiplication property of 1. Here's a new property, the multiplication property of negative 1. For any real number n, n times negative 1 is equal to the opposite of n. So if you want to find the opposite of a number, just multiply it by negative 1. Another new property, the associative property of addition. For any real numbers a, b, and c, we can add those numbers up and group them any way we like. And in our example, on the left side, we can group a plus b, add that, and then add c. But that would be the same sum as if we grouped b plus c and added those two numbers first and then added a. This property bears a demonstration. So here are three numbers, 5, 12, and 53. And on the left side of our equation, we group the 5 and the 12, and we add them first. On the right side, we group the 12 and the 53 and add them first. That gives us two different addition problems. On the left, 17 plus 53, and on the right, 5 plus 65. Those problems don't look alike at all, but their sums are the same, 70. The associative property also works for multiplication, and that bears a demonstration. We have three new numbers. For multiplication, 5 times 9 times 3, and on the left we group the 5 and the 9 together to get 45. On the right we group the 9 and the 3 together to get 27. And once again, we are now looking at two different multiplication problems, 45 times 3 and 5 times 27, but the product, 135, is the same for both multiplication problems. The associative property does not work for subtraction and division, and a demonstration is in order. Here's three numbers being subtracted, 9 take away 5 take away 3. But on the left side, we do the 9 take away 5 first and get 4. On the right side, we do the 5 take away 3 first and we get 2. And then we're left with two different subtraction problems, and they do not have the same difference. 1 is not equal to 7. That's why we use that symbol on all three lines. The equal with the slash through it means is not equal to. The associative property does not work for subtraction. And it also does not work for division. And here's a demonstration. We have 12 divided by 4 divided by 2. But on the left side, we group the 12 divided by 4 and do that first and get 3. On the right side, we do the 4 divided by 2 first and get 2. And then on the left side, we're left with 3 divided by 2, which is 1.5. And on the right side, 12 divided by 2, which is 6. And of course, 1.5 does not equal 6. The associative property does not work for division. And here's another important property, the distributive property of multiplication over addition or subtraction. For any real numbers a, b, and c, a times the sum of b plus c is equal to the product of ab plus the product of a and c. Or, when we use subtraction, a times the difference of b and c is equal to the product of a times b, take away the product of a times c. Demonstrations are in order. On the right side, we have 3 times the sum of 4 and 5. And on the left side, we have the sum of the two products. The first product is 3 times 4, and the second product is 3 times 5. The left side is the way we've learned it with order of operations. Do what's in the grouping symbols first. 4 plus 5 is 9, and we end up with 3 times 9. But on the right side, the distributive property says we could also do the 3 times the 4 and the 3 times the 5 and add those two products. And when we do, we find that the sum of 12 and 15 is 27, and the product of 3 and 9 is also 27, an example of the distributive property of multiplication over addition. And now a demonstration of the same property, distributive property of multiplication over subtraction. On the left side, we have 3 times the difference of 4 and 5. And on the right side, we have the difference of two products. The first product is 3 times 4, and the second product is 3 times 5. Well, on the left side, 4 take away 5 is negative 1. And on the right side, 3 times 4 is 12, and 3 times 5 is 15. So we have a times problem on the left, 3 times negative 1, and a subtraction problem on the right. But the answers are the same, negative 3, and this is an example of the distributive property of multiplication over subtraction.